the truth.
In real life, things for the most part don't come out exact. We don't have exact points. People, a batter doesn't always every day bat his exact batting average. Sometimes he has good days, sometimes he has bad. It comes out as an average, but stuff happens, okay? Thermometers sometimes don't work exactly properly. People don't exactly work properly, okay? So things don't always come out exact. So to that end, we have another method, a way more realistic method to find these equations, and that is using what's called linear regression. We call it regression because up to this point, we've been going from the equation to the points. Now, I'm going to give you a whole bunch of points, and they're not going to line up very well, and not exactly anyway. And you're going to regress, you're going to go backwards, back to the line. Much like the point-slope formula, but that only found you the slope. I'm going to give you a bunch of points, and they're going to actually allow you to find not the exact line, but an average line, if you would.
Hey man, check that out, huh?
For instance, if I had a bunch of points here, and I see they don't line up, I told you stuff doesn't always work out. And I had measured these points as temperature or something. Temperature versus date or something. Now, there is a line that's pretty close to them, okay? And that would be close enough for my sake to predict, some other points, if you would, in that trend. Here's another one. Now this one goes a different way, but it's still an average line for those points. It's not always a line, and it doesn't always work. These points are all over the place, and if I drew a line, it wouldn't be very good. Okay, so it doesn't always work. And sometimes it isn't a line. Sometimes it's a parabola. Now, we're not going to be dealing with that in this semester. We're just going to do linear regressions, okay? But if we can find that function that predicts on the average where these points are at various spots, once again, we'll be able to predict the future.
You'd like that, wouldn't you, boy?
Oh yeah, it'll be quite useful. So to find linear equations,
Plastic machine, Spock. You can't argue with a machine.
we can use our calculator if we can input points. Well, get out of this town. I just showed you how to input points, and then the calculator's going to give you the equation. We're going to be using stat to input points. Remember, I just told you how to do that. And we're going to plot some data points, and then, of course, we'll look at the picture. If we hit stat calc, I'll show you where that is in a second. There's an option under stat calc called linear regression, and if all those points are in there, it's going to look at those points, and the calculator will figure out the average line, the ax plus b equation that you can use. Now, there's a lot of math to this, and actually we're not going to do the math. Okay, I just want to show you how to do it on a calculator. It'll be of great use to you. Okay, and that's kind of the method we're going to do.
We went from good to sensational.
And it's gonna give me an a, which is going to be basically the slope, the number in front of x. It's going to give me a b. You're used to that. That's going to be the y-intercept. And we'll talk a little bit later about what the other two numbers it gives us are, the r's. Okay?
I know that, dude.
That's the slope, the first number it gives us.
I know you are, but what am I?
And that's the y-intercept, the second number it gives us, the b. You already knew that, okay?
Pay attention, boys. I'll show you how it's done.
Okay, let's see. We collected this data from 10 students last semester. The blue numbers are all their homework, their final homework grade, and the green numbers are all their final exam grade. And we think that they correlate to each other quite well. Okay, well, we're going to find out, first of all. Okay? Now, first thing we have to do is get this data into the calculator. Okay, let's get moving. You're going to have to plot it. Remember how you do it. You use the stat button. Okay, let's get that data in. I'm going to do it with you. Here we go. Bring up the calculator, and I'll go stat. And the plotter's already on, so all I have to do is go into the editor. And I'm going to go over and put in my numbers. I'll read them off for you for list 1. 85, enter. 35, enter. 60, enter. 79, enter. 100, that was mine, enter. 90, enter. 41, enter. 65, enter. 95, enter. 71, enter. Okay, now let's get back up to the top of list 2. We'll cursor over and up, up, up. Okay? Gotta go all the way up to the top. Don't think you're up to the top until you're next to that 85. Okay. Now let's see. 136, enter. 40, 40's next to the 35, enter. Okay, 88, 88 next to the 60, enter. 125, enter. 165, enter. Now these are exam grades out of 200, okay? 145, enter. 52, enter. That person didn't do their homework. 98, enter. 155, enter. And 111, which should be right next to a 71. If you did it right, enter. Now we've got the data in. Let's graph it, make sure that we can see it. Well, what's going on here? We have to zoom out, don't we? But it's there. In fact, I'm not even going to take the time to zoom. Let's clear, and let's get a regression line. Let me show you how to do it. We're going to go into Stat, hit your Stat button. Now you do not see regression on this, because this is the editor. We're going to have to move over to a different menu under Stat called Calc. The way to move over is to use your cursor. Okay, so hit your cursor, and you'll see Calc will become darker, and you'll see a bunch of things. We're going to use number 4, linear regression. Remember I told you there were other types of regressions, quadratic regression, cubic regression, etc. But in this class we're only going to do linear regressions. Okay, so you can either cursor down, I'll cursor down to 4 so you see where I'm at, or you could just hit 4 and hit enter, and it's going to go when I hit enter and sniff that data and figure out the best line, the average line if you would, that will fit through them to be closest to all those points. I'll have to hit enter again. Took a little number crunching, but as you can see in the form y equals ax plus b, it's telling me that if I write an equation that has a slope, the number in front of x, of 1.919412739, geez, is that close enough for you? And a y-intercept of negative 26.31, that's close enough for me. Okay, that's gonna work out for us. Well, let's try this. Okay, let's clear that out. Okay, and I'm going to put, as you can see, I've already calculated that y equals 9.14. Now I asked you to find the regression line. That's what I mean, the y equals mx plus b line. And we found, basically, I'm rounding, y equals 1.9x minus 26.3. Now, who cares? Well,
Are you pondering what I'm pondering?
now that you've gotten all that old data and you've put it into a regression line, you can use that line to predict other people's grades, okay, or predict the future, as I said. I'd ask you to predict the exam grade of a student doing only doing 50% of his homework. What do you think that person's going to get based on the regression line from this data? Well, let's use our calculator. We can type that line. Let's clear out. As 1.9x minus, we're trying to find the y with an x of 50. So I'm going to type 1.9 50 times 50 minus 26.3. And that'll give me y, which is supposed to be the final exam grade. This person got about a 68.7. We predicted, using our linear regression line, that this person's going to get a 69. They're going to fail. And that's predictable since they only did 50% of their homework. So we can use this regression line to predict all kinds of things once we have it. And how did we get it? Well, we regressed back from some earlier data. That's what we did. Now,
Hey, Doc, wait! I want to ask you something.
okay, we know that the A goes in the slope part, the number in front of the x. And the B is the y-intercept. What are those other numbers? Well,
All in good time, Minus Pretty. All in good time.
I'm going to tell you, relax, Frank. Those are the correlation numbers.
Do you mind telling me what this is all about, mister?
Okay. Well, let's a correlation measures the quality of a forecaster. Let's look at these two. Okay. Given that data, we have the green forecaster line and the blue forecaster line. Who do you think is a better forecaster of the data? Of course, one has much widely more scattered data. Okay.
Certainly.
So, yeah, you're the one that's closer to all the data. So there's some lines are going to be predictors, but they're not going to be very good predictors. Correlation is a measurement of how good a predictor it is. Okay? Not just that. It tells how well it fits. Now, it's always going to be the number they give you for the correlation, the R, if you would, is always going to be between the numbers -1 and 1. If it's close to 1, that means it's a good positive correlation. That means as the x value gets bigger, the y value gets bigger, and it's a good predictor. Okay? If it's close to -1, that means it's a good predictor, but it's a negative predictor, meaning that as the x value gets bigger, the y value gets smaller. But that's okay, I can deal with that. But it is predicting, it's just predicting inversely, if you would. If it's close to 0, then it's not a reliable relationship at all. For instance, this one would be a pretty reliable positive correlation. Okay, the points are pretty close to the line, as you can see. And as the x value gets bigger to the right, the y value gets taller, goes farther up. Okay, and this happens to be, if I put those points in, trust me, comes out to 0.816, and that's about 1. That's close to 1, okay? Not perfect, though, is it? It's not a perfect predictor. That's life. Now, this one would be a pretty reliable negative correlation. Notice as the x gets bigger, the y value goes down, okay? But it's still a good predictor.
Excellent.
Okay, in fact, it's a -0.829. It's very close to -1. It's called the correlation coefficient.
Whoa!
This is a terrible correlation. The points are all over the place. If you tried to use this line to predict anything, you would be a fool.
Oh, very bad. Definitely unacceptable. Yeah.
It is moving up a positive slope, so it is a positive correlation. But look how close it is to 0. 0.008. Almost no correlation at all. It's just a coin flip, really. Okay?
Allow me to demonstrate.
Okay. Let's do it again. If we take the statistics from the last 7 4th of Julys, okay, I'll just try and relate two parts of the data. I'm going to try to relate the number of riders on the Metro on the 4th of July, each of these last 7 4th of Julys, that's in blue. And that's in tens of thousands. Okay? And then how does that relate to how many car accidents occurred in the district on those 4th of Julys? We can use this linear regression, perhaps, if it's a good correlation, to predict how many car accidents are going to be on that day. Why do we care about that? Well, that's going to allow us to perhaps figure out how many police officers to have on duty that day, or how many ambulance people to have on duty that day. It's going to be of great use. Okay? So that's why we want to be able to predict type stuff. Okay, well, it's your job. You got to clear out that old data and plot the new data. So get moving. Get that old data out of there and put the new data in. You're going to use, remember what you're going to use, the Stat button and then the Edit button. Okay? Let's give it a go. If you can get the data in, the calculator, of course, will do the rest. It'll calculate your regression line. So let's see. I'm going to hit Stat. Oh, got to turn it on. Hit Stat and the editor, which will be 1. And let me get in here, and I'm going to start deleting and putting in numbers. Or overwriting even. I'm going to put 102, enter. 145, enter. 167, enter. 80, enter. 156, enter. 220, enter. And 99, enter. Now the rest of these values I'm going to have to delete. So I'm just going to delete, 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 and I'm down. Okay, now let me get to the top of the list 2, right across from the 102, and I'll put a 22, enter. 19, enter. 15, enter. 26, enter. 14, enter. 9, enter. And 20, enter. 20 should be right across from 99, and the rest of the numbers I'm going to have to delete, so I'll use my delete button. Delete. I need about 3 deletes, it looks like. Okay, and they line up. The 99 lines up right across from the 20. Okay, now my graph's probably too far in, so I'm not even going to worry about looking at the graph. Okay, what I'm going to do is create a linear regression line. Remember how to do that. I'm going to click on Stat, and then I'm going to have to move over to Calc, because I'm telling the calculator to calculate this for me. So I'll cursor over to Calc, and the linear regression is number 4. So I'll cursor down to that and hit Enter, or hit number 4. And it's asking me, do I want a linear regression AX plus B? And I sure do. So I hit Enter. Takes a little while, and son of a gun, it's where the slope is minus 0.111 something, and the y-intercept will be 33.3 something. I hope that's what you're getting. Okay. Now the correlation value is very good here. Okay. Do you see that the R is 0.959? That's very good. That's very close to 1. And R squared is just the square of that. Okay. So it's a negative correlation. So as the X gets bigger, in other words, the more Metro riders we have, the less car accidents we're going to have. So we may want to pump up and maybe let people ride the Metro for free on the 4th. I think they did that actually a couple times. How would we use this data to predict how many accidents we think will occur in DC with 50,000 people riding the Metro? Well, let's write the equation. The slope will be the A value, negative 0.11, times the 50. So I'll put it in parentheses, plus the y-intercept, plus 33.3. Close enough. Enter. With 50,000, it predicts 27.8 people. There'll be 27.8 accidents. Huh. I'd hate to be that 0.8 person. I wonder how many accidents would occur if nobody ride the metro. If nobody rode the metro, that's pretty easy. You can do it in your head, but let's just show you. It would be negative 0.11 times what? Times 0 plus 33.3. So the prediction with nobody riding the metro, the little course is higher. We're going to have 33 accidents, 33.3 accidents. So you see how we can use a regression line once we put in the data to predict the future and hopefully use that for various things to react to. Okay?
I want to tell you my secret now.
Okay, now I got some really cool stuff to show you. Consider that there are other types of regression because there's other types of functions.
Excuse me, Professor Brainiac.
Do you remember the functions, some of the functions that we've covered before this semester? They're kind of like standard function types. Certainly the first one we just looked at was linear.
Well, duh.
Remember that a linear function is of the form y equals ax plus b, where a is the, remember, the slope and b is the y-intercept. Looks something like this function here. Okay, and if we looked at it on a graph, well, it's linear, so it would be a line. Whether it went downhill or maybe a constant linear function, it looked something like that, or going uphill, or whatever. The point is it would be a straight line and it would go on forever. But there are other functions, remember? What about the exponential functions that we looked at? They were of the form y equals a times b to the x. For instance, this function here. Now they still had an a and a b, note. It was just in a different form. You had a coefficient and then a base that got, exponented, if you would. The picture looks quite different, though. It's not a line. We had really two types, if you would. We had exponential decay that kind of accelerated in its getting smaller, if you would, and exponential growth that wasn't really a line, was it? It kind of accelerated in its growth. It got bigger faster, if you would. Okay, and then there was even another type, very different,
Certainly.
quadratic type functions. And they were of the form y equals ax squared, the number in front of x squared was a, and then there was an x term, that was b, and then we also had a third one in this one, c. For instance, here's a quadratic function. Now these ones looked very different on a graph because they kind of came back, if you would. They were parabolas. They either had a parabola that we say holds water, like this one, that had a minimum, or one like this that had a maximum. Okay? So these are all very different pictures, as you can see. Now, let's get back and try and do another regression, if you would, and I think you're going to see something a little different this time.
Allow me to demonstrate.
Consider this data that is a list of how many hits have occurred on a website as it goes on in time. For instance, in week 1, it had only 138 hits. In week 3, 259, and so on. As you can see, as the weeks increased, so did the hits increase, I guess from word of mouth or whatever. So one might guess that since they're both increasing kind of at the same, well, we don't know, we'll have to look at a picture, but one might guess that we could perhaps do a regression of this, a linear regression as we've done, and perhaps maybe be able to predict how many hits we'll have in the future. So let's try and do a linear regression, just like we did before, of this data. First thing to do is, of course, input the data. So I'll hit the Stat button and go to Edit and hit Enter. And let me put in quickly the week information. Put a 1, a 3, a 5, a 7, a 9, an 11, and a 13. And then I'll go and put the hits information, which is 138, 259, 486, 913, 1713, 3215, and 6034. Okay, now I have the data in there. I can't resist. Let's take a look at the data. So I'll graph, and I guess I'm zoomed in properly. Remember how to zoom properly for statistics data? I'll go zoom, and I'm going to go down to my old buddy zoom stat, which is number 9. You could have hit 9 and hit enter, and now I can see that this data, maybe it's not quite linear, is it? It's kind of bent. It looks like I know they're both increasing. Both lists are increasing, but it looks like one is increasing faster than another. I want to say the word acceleration. But anyway, we'll continue on, and let's see what we do. We hit Stat, and we'll go over to Calc, and go down to do a linear regression to get our A and B. And if I hit enter, and enter again, it thinks a little bit, and it tells me that it could do it, and the A was about 443, say 0.34, and the B was negative 1,280, as you can see. I do have a little bit of bad news, though. It looks like the correlation value is about 0.89, which really isn't that impressive. Let's take a look at this and see what the line looks like in relationship to the data points. So I'll have to put this in as a line, and I'll use that information. So I'll hit y equals, and I'll say 443, I'll round a little bit, 0.34 times x, of course, and then minus 1,280.8. Now let's take a look at that and the data at the same time. I'll hit graph, and you can see that it is about the average line, if you would, for that data, but actually very few of the points are even, in fact none of them are really on that line. So, and you can see why the correlation isn't very good. It's not going to be a very good predictor, if you would. Well, now I've got some good news for you. Consider what we can do is we're going to hit Stat again, and we're going to still do a regression. So we go over to Calc, and we're going to do it the same way, except this time I smell that looks awful lot like exponential growth. I'm going to go down. Did you know that your calculator can do what's called an exponential regression? Okay, and this may be a little bit closer. Let's try an exponential regression, and that's down at the end on number 0. And I'll hit enter, and enter again. Note, by the way, I don't have to say list 1 and list 2. If I only have a list 1 and list 2, it'll automatically use those two lists. Okay, I only need to say the list if I want to use something else. And it thinks a little bit. Boy, that took a while. And once again, I get an A and a B, but it's telling me that the form is a times b to the x. It's an exponential function. And holy mackerel, look at the correlation. You could kiss this. You love this correlation. It's 0.999999. Doesn't get much closer to 1 than that, does it? So let's try it as a graph. Okay, so I'll go into y equals. I'm going to kill that old linear function because it wasn't very good anyway, and I'm going to put in this exponential function. The a in this case was 100.72. That's what the calculator told me. Of course, I'll have to put parentheses now. Times, and the b is 1.37 approximately. And remember how an exponential function works. To the x. So I'll get the to the button and the x. And let's take a look at this Johnson. Takes a little longer to calculate, but look how close it goes through. I think it goes through every data point. That's why, as you could see, or you could see before, the correlation is 0.999. It's an excellent correlation. It's going to be an excellent predictor, if you would. Okay? So,
Allow me to demonstrate.
let's consider this is the function that we want to use to predict. Well, what would we want to predict?
There's something I have to ask you.
Well, perhaps we'd want to know in a future week what how many hits we're going to have. Well, we can use that function to do that. That's why we create these regression functions. So I'll put the 20 in for the x, and guess what?
Cool.
It's going to tell me how many hits I have in the 20th week, way in the future. Very, very powerful. And in this case, because we used a new type of function and the correlation was 0.999, very close to 1, because we used a new correct function, more correct function, it's going to give us a very accurate future guess. Well, that's not the whole story.
Thank you, sir. May I have another?
Let's take a look at another one, more business-related data here. What we have going here is we're selling the signed jersey of a famous football player. And I have the prices that they tried to sell things for in list 1 and the number of sales that occurred in list 2. Okay? If they sold it for $20, they found that they made 30 sales that day. And if they sold it for $30, they found people thought that it was worth more, so actually more people bought it. This happens in business. And that went up, and then, well, if you look at the future data, as it went up too high, people went, well, that's just too expensive, I can't buy it, and it went back down. So we may want to use this as a predictor, so of course we'd want to do a regression. Well, we'll try that with our, let's insert the data into our calculator first. Let me hit Stat and Edit. Now, I have the old data from the last problem, so I could clear it out. In fact, let's do that. I'm going to hit Stat, go down to Clear List. I could overwrite it as well, but I'm going to just show you how to do this just so you remember. And I need to clear List 1 and List 2, so I'll go Second 1 or L1 and hit Enter, and it told me that it cleared it. And then I'll hit Stat, and once again go down to Clear List, and I need to clear List 2, so Second and List 2 and hit Enter. Now they're gone, and I can put in the new data. So let's go Stat, Edit, and I'm going to put in 20, 30, 40, 60, just working my way down, 80, 100, and 110. That's the data that was collected. And for 20, there were 30 sales. For 30, there were 50 sales. For 40, 65, and on down, 75, 72, 50, and 25. Now I have the data. I think it would be very useful to plot it. Taking a look at this graph of the plot of the data points, hitting Graph, I see, oops, I did it again. I need to zoom to Stat so I can see all these points. Every time I change problems, I should do that. So I zoom to number 9, Stat, and there they are, and that certainly is not a linear situation, is it? I smell quadratic. So I'm not even going to waste my time trying to do a regression, a linear regression here. Did you know that you can do a quadratic regression? Okay, based on these points. And we do it the exact same way. We just have to be able to recognize what type of a function something is. Now this is certainly going to be quadratic because it comes back, if you would. It has a maximum. So let's do it the same way. We'll go to Stat, go over to Calc, and now we need to find quadratic regression, and pretty cool, it's number 5, quadratic regression. Now, you should expect that you're going to get not just an A and a B this time, you're going to get an A, a B, and a C in addition to your correlation number. So I'll hit Enter. And son of a gun, it did give me an A, a B, and a C. And it even told me, just in case I'm stupid, don't say anything, how to set this up. Y equals ax squared, A being the number in front of x squared, B being the number in front of x, and C being the constant. And this is a pretty good correlation. As you can see, we got 0.99 for r squared. Okay, so we can deal with that. So let's put it in as a function. I'm going to use these numbers and take a look at, see how closely the actual graph comes to the plotted data points. So I'll put in y equals, this might take a little while, let's see, negative 0.024 x squared, so I'll have to go x to the tooth, okay, and then the b was 3.12, so plus 3.12 x, that's the number in front of x, and then the c was negative 22.13, so minus 22.13. And son of a gun, if I graph that, get out. Look, oh, it doesn't, it's not exact, but it comes very close. Doesn't really tell me the exact maximum, does it? But as you can see from your correlation, which was 0.99, it's a very good predictor. So I think it's fair to say that a quadratic regression was very appropriate in this case. Basically because it went up and came back down. It had a maximum. This was the function that was predicted by the calculator. Now, why would you want that function? To predict future values? Well, in this case, in business, I'll bet you would want to predict the price that was appropriate to maximize your sales, wouldn't you? Well, the maximum would be the vertex, and do you remember? Negative b over 2a is the x value of the vertex. Now, you could use a calculator to do this as well. You could calc the max of this function. Since you put it in already, you could calc the max of the graph. But we'll do it by hand here. Negative b over 2a, in this case, is what? It's going to be negative 3.12 over 2a. A is negative 0.024. And if I actually calculate that, it comes to $65. So let's get straight. This is the x value. This is the price. This is the price that would maximize sales. Now I can plug 65 in and find out exactly how many sales I would have. Of course, I would plug that into the blue function above.
Excellent. And
I could find out that the most sales I could possibly have are 79. And that's if I price my signed jersey at $65. Very practical use, if you would, of doing regressions. Okay? Okay, well, go do your homework and get predicting the future.